Alright, hopefully this will record properly. So, the assignment is structured like this. You can basically ignore most of this. It doesn't really tell you much. The importance, well, this could tell you stuff too, but the main gist of this assignment is just making these plots. These plots are a little difficult and very time consuming, and you're going to have to make 3 different plots, or if you want to, you can combine them all into one plot and just differentiate the data that way. But for right now, I'm going to show you how to plot Cane Creek. I'm going to show you how to do all of the Cane Creek ones for this data set, and I'll show you an example on how you can combine all of the data sets onto one plot with some of the examples, well, some of the problems that I did on this assignment. I've already finished it, except for 6B. 6B, I can't find anything with the bicarbonate in order to make a plot against the calcium over sodium. So, we will start with the pH versus the temperature against the temperature that is set as a log. So, to get the data, just go on iLearn, download the FWR data Excel file. You'll hit download. You'll get that. Just open it. Alright. You'll have to enable editing. And first we'll start with differentiating the data, like color coding wise. It'll make it easier, so like when you're doing the different plots for the different watersheds, it'll be easier on you. So just scan. If you have the white plus sign, that'll equate to it being like a scannable thing or a highlighter. So you go to that. I'm going to make sure that I've highlighted all of Cane Creek. I'm going to click home. I'm going to make it light green, and I'll make falling water like blue or something. That way I don't accidentally select falling water's dataset. There you go. Alright, so pH versus temperature. You can create a new sheet by hitting this plus sign down here. I will just copy and paste these data values to the new sheet. So we're going to take the pH, Control C, go over to the new sheet, Control V. This will be our pH. And I'm going to create a space in between here. Actually, you don't have to. I will. Temperature. Go to temperature. These are all of the temperature values. Oh, I accidentally Control paste. Let's copy this onto the temperature. And then he wants us to take the log of this temperature and graph it with the pH. So we're going to type log of this. Oh, you got to put a parentheses. So you're going to type equals log, open parentheses. You're going to click this and then hit enter. And then now this will be a function on this cell. But if you get this black cross thing, it'll copy and paste the function but with different cell values. So this will be the log of C2, and if you go down one, it'll be the log of C3, log of C4, so on and so forth. Now, time for the plot. Scan the data values, and then go over to insert. You're going to go over to this dotty plotty plot thing. You're going to click this thing right here. Now, it's important to check which is the y and which is the x-axis. So he wants us to graph it as pH versus temperature. When you're doing a versus, it's always y versus x. But right now, it's x versus y. So to change that, you're going to right-click the data, hit select data, and then you're going to click edit, and then you're going to delete everything here except for the equal sign, and then you're going to scan what you want to be your x value over here. And then for the y value, just delete that, and you'll highlight the y values that you want. And now we have our plot for Cane Creek. Cane Creek pH versus temp. And you'll want to add titles, of course. Temp. And it's always a good idea to add a trend line. That way you have a line to reference when you're providing an explanation on the correlation of data. So as pH goes up, temperature also goes up. And if you want to make it like even more obvious, go to this arrow next to the trend line, and you'll go to more options. And then you'll want to go to this bar value thing right here on the Format Trend Line menu. You'll scroll down, hit Display Equation, and then you have a guaranteed ratio right here with the mx of the equation. So that is our graph, or plot, whatever, for the pH versus temperature. Now we will do sodium versus chloride, millimoles per liter. So we'll go back, we will go to sodium, we will copy, sorry about that, copy, and paste to the new one. This is already in milligrams per liter, so all we have to do is divide it by the molar mass. I believe the molar mass is 23. I could be wrong, but I don't feel like looking it up. So you can just copy this value by the black plus sign, and it'll just copy those values. So now we will divide. So now this will be our sodium as millimole per liter. And then you'll hit the equal sign. You're going to click the first value here, and then you're going to do a /, and then you're going to click the thing that you're going to divide by. And then you'll just hit enter, and you'll have the first millimole per liter data value. And to make the work easier, just copy this whole function with different data values to get more. And now we have to make our, I'm going to push this to the side because we don't really need that for this current one. If I could push it, that'd be great. There we go. And then now we have to do the chlorine. Chlorine. Yee. We're going to go over to chlorine right here, copy, and paste. Our molar mass, I don't feel like typing out molar mass, 35.45. Copy it with the black plus sign, and then this will be our Cl millimole per liter. And then we just do the same thing as we did with sodium. Click here, divide it by the molar mass to get the millimole per liter. Copy the function. Now I'm going to move this data set over here so it can make it easier to highlight all of the data that I want to graph and create a plot that way. So once when you highlight it, you'll want to hover onto the side of the box until you get a arrowy plus sign. And then you're going to move it over next to your other data that you want to graph it against. Highlight the two columns, click Insert, Plot, Scatter. You're going to want to change the X and Y's over by Select Data, Edit the X values will be the chlorine millimoles, which is this column right here, and the Y values are going to be the sodium millimoles per liter. Hit OK, hit OK again. Here is Cane Creek sodium millimoles per liter versus chlorine millimoles per liter. Again, just add titles and add a trend line. You don't have to do an equation, but the equation makes it easier for understanding the ratio between the two x's. Alright, so that one's done. We'll push that to the side. Now we do the nitrate millimoles per liter versus the DO. Alright, nitrate, a copy from this cell to our new sheet so it doesn't get too cluttered. This sheet will definitely get cluttered. NO3, the molar mass of nitrate. You know, I will look this one up. Alright, nitrate. 62. Oop, wrong one. That's mine. This is the one I will be using for the this video. 62. Copy that down the column. The millimole per liter equals this divided by the millimole. Again, just copy the function. There we got. Milligrams per liter divided by the molar mass will equal millimole per liter. And then, fortunately, we don't have to do anything with DO. We don't have to, like, convert it to something else for graphing. So you just copy this. And boom shakalaka. Highlight the data, insert, plot, scatter. I always like to check that the axes are correct. So x value and DO. Oh. And the Y value will be the nitrate millimole. Okay. Cane Creek NO3 millimole per liter versus DO. And then you just add your axes and your trend line and you're good. Alright. There we go. Alright. So that's number 3 done. Now we will do milligrams per sodium milliequivalents versus the sodium, oh, whatever I said, milligrams per milligrams, magnesium versus calcium. I'm very tired, I'm sorry guys. Anyways, we will copy this over to the sheet, we will paste the molar mass of milligrams magnesium is 24. We will highlight and paste with that X, not the X, the black plus sign. And then the charge will be 2, because with equivalence we take the moles and multiply it by however many charge it is. So now we will mequilifer per liter, and now we will do equals, do a parentheses so that it'll do the division first before the multiplication, and then close the parentheses, and then you'll hit the star to signify a multiplication, and then you'll click the thing you want to multiply it by, and then you'll just hit enter. And then you can just copy that function with different data. Alright, so that's the magnesium. And now we will do the sodium. 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 There we go. Control C. Control V. Molar mass. I think I said like 23, right? Yeah, it's 23. 23. Got that. Since sodium is a +1 charge, I'm just gonna ignore the multiplication with the charge because you're just multiplying it by 1. So milliequivalents meters is going to equal that divided by the molar mass. Now you're just gonna copy that function. And down here, I'm going to create the column with the magnesium over the sodium. And then you'll just hit equals that divided by, oh shit, wrong one. This divided by that. And then you will just go down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'll go 6 just in case. But yeah, if you go any further ahead, you'll just get this error. Just delete that error, and you'll be good. Magnesium over calcium, and now we will do the calcium one. All right, where's calcium? There it is. It's next to the calcium carbonate. And you'll just do that. The molar mass of calcium will be 40. Just copy and paste those data values. Ooh, hello. Charge of calcium is 2. And you are just gonna do the same as you did with the magnesium, equals this divided by, parentheses, this divided by this. Ooh, hello. There you go. And then you will multiply it by the charge, and then you'll just, boom. There you go. So now we got our calcium. Now we can do the magnesium divided by the calcium to get that axis. So equals this magnesium divided by that calcium. And then just drag it down. And now we can make a plot for number 4. I think it is, yes. Insert plot, scatter. Select the data, click edit, switch the axes. So this should be our X, this should be our Y. Okay, click OK again. I'll just put a title on here, and then call it quits on that one. Cane Creek. Milligrams. I keep saying milligrams. Let me stop. Alright, versus magnesium over calcium. No equivalents per liter. Alright. That one. Shoo, fella. Bye. Okay. Now we will do the calcium milliequivalents versus the alkalinity. I'm sorry, little kid. Here's a cat in the corner. Anyway. Alright, calcium. Oh, shoot. I didn't copy it. There we go. Cool. mass, charge 40 to boom, and then milli equivalents per liter. I am tired. Equals that divided by that. Multiply it by the charge. Copy and paste the function along the column. I got that. Alk for alkalinity. Alkalinity will be measured in calcium carbonate. Just copy that function, not copy that function, copy that column, paste it over, and since it's already in milligrams per liter, all we have to do is divide it by the molar mass. Calcium carbonate is a neutral substance, so there won't be any charge. So the mill equivalents will equal the millimoles per liter. So equals that divided by the molar mass. And we'll just boop, and I will move this column over next to the move this column over next to the other data set, highlight it, insert column, scatter plot, and then we will select the data, click edit. The X series will be the alkalinity, and the Y will be this. We'll click OK, and we'll click OK again. Alright, and then there's titles and red line. And this one is the Cane Creek mill equivalents per liter versus alk equivalents per liter. And that one's done. We'll just scoot that over to the side. And the last one will be the magnesium over sodium versus the calcium over sodium. So we'll do magnesium again. I don't feel like, let's copy this and put it right here. Minus. This will be 1 mole per liter equals this divided by that. Copy that function. And then we will do sodium. I did sodium earlier. Oh wait, no, it's literally just this same thing. So we'll just paste it there. And then we will make a column for the magnesium over the sodium. And then what equals that divided by the sodium. Drag it down until you get errors and just delete them. Yep, I'll just... Oh, there we go. And then we will make a second column for the calcium over sodium. And then calcium. I think we did calcium earlier too. Yeah, it's literally right here. So just copy, paste. This is the molar mass. Millimole per liter. And we will get millimole per liter when we do this quick division of the data over the molar mass, copy the function, not move the cell, copy the function along the column, and then we just divide this first data for the calcium divided by the sodium, and then we will copy the function across there. And then we will graph again. Scatter, right click, select data, equals, that is our x, this is our y. Okay. Styles trend line. Cane Creek. Magnesium over sodium, millimoles per liter versus the calcium per sodium, millimoles per liter. That's it for that one. Hopefully that helped. I will also show another aspect in how you can combine like different data sets. So I'll show you how to combine like Cane Creek with the falling water data with the whatever the third one is. So I will go to one of my data sets. Yeah, I'll show you how to combine the nitrate with the DO. So you're just gonna wanna think. Oh, I know what I did. Okay. So this was the nitrate data. This is the molar mass. And this is the millimole per liter. And that's just the DO. So we will move some of the data around. So we will move everything basically in a row. So put them all next to each other. Ooh, hello. There we go. Okay. Yeah, so like these two were I'll just put C for these are the Cane Creek ones. These were the falling water ones. These were the Taylor Creek ones. And then these were the millimoles per liter. Millimole per liter. DO, DO, DO. So, once when you get all of your data in a row like this, just scan it all, and then click Insert, Data, Scatter. Now you're going to get a bunch of crap. So, to fix that, just click Select Data, and then you're going to edit like 3 different series. So for the first series, we'll make that Cane Creek. Cane Creek. And then we will scan our X value, which will be the DO, and the Y value, which will be the, oh, don't type it, just scan the data, that. And that's Cane Creek. And then we will do, I think it's falling water. Oh. Sorry, there's a little bit of input delay from my keyboard. Okay, so our X value. Our X value will be the DO, the Y value Oh, come on. Oh, there you go. Our y value will be that. And then the last one was Taylor Creek. Forget the Y. Taylor Creek. So our X value is going to be this. Our Y value is going to be this. And then once we have your 3, just delete the other ones. And then you'll just hit OK. And you'll have a plot with 3 different data sets on there. And then you can just label this, ooh, hello. That's a type of title there. NO3 millimole per liter versus DO. And then you could just do the usual title. You could do like a tread line based on whatever data set you want to use. I'll just do Cane Creek. And then, yeah, hopefully that helps. Thank you for watching.